Welcome to the DX Today podcast, where you get facts and no hype. And welcome back to the Deep Dive. Today we are wrestling with a security crisis that is really fundamentally redefining enterprise risk. We're diving deep into this phenomenon known as shadow AI.
Right.
That's the unsanctioned, unmonitored use of these incredibly powerful generative AI tools, things like ChatGPT, Claude, all those specialized coding assistants by employees right across the organization.
And the source material we've been looking at, it's genuinely alarming.
It really is. They don't frame this as, some minor compliance headache.
Not at all. They use words like existential, an existential organizational crisis. And they say it's far, far more perilous than the shadow IT we all spent the 2010s trying to get a handle on.
So our mission today is to break down exactly why it's so dangerous, but more importantly, to outline the comprehensive strategic solution.
And what's fascinating here, and the sources are so clear on this, is that the old strategic playbook just fails. A strategy of pure prohibition, just trying to block every single Gen AI domain at the network edge. It's completely destined for failure.
It just doesn't work.
It can't. The sheer overwhelming demand for cognitive assistance and productivity gains, it just means that employees will always find a way around the bureaucracy.
They'll use their phone.
They'll use personal devices, mobile networks, or they'll find some brand new unclassified model that IT hasn't even heard of yet.
Okay, so the focus has to shift.
It has to shift immediately. For any leader, whether you're in IT, security, legal, this is critical. We're not aiming for eradication because that's, frankly, impossible.
Right.
We are aiming for control. Control through what the sources call a secure enablement architecture.
And for you, the listener, that's what we're going to break down. We're going to get into the entire containment framework, combining the policy reforms you need, the sophisticated technical discovery, the enforcement, and this is key, providing safe alternatives.
You need to understand the full solution. That's the only way to turn this chaotic risk into a managed strategic asset.
Okay, let's unpack that core distinction right away, because shadow AI is not just shadow IT 2.0.
Yeah.
We really need to get the mutation here.
Yes.
If you think back a decade, shadow IT was employees using personal Dropbox account, maybe a Trello board for a project.
Exactly. The risk there was data fragmentation.
Yeah.
Or, access control issues. You knew what the software was, you just didn't control who could get into it.
But you knew what it was.
That's the crucial difference. In that older paradigm, we were dealing with known goods. When you put data in Dropbox, it was static. It was just stored.
Right.
Shadow AI introduces what the sources define as a probabilistic risk. That's a huge shift.
What does that mean in practice?
It means when an employee inputs proprietary data, we're talking intellectual property, source code, confidential HR notes, they are transmitting it into an opaque neural network.
And that network isn't just a hard drive in the cloud.
Not even close. It doesn't just store the data, it actively processes it, it learns from it to understand context, relationships. And that processing introduces these layers of unpredictable risk that security teams just can't easily audit or roll back.
So what kind of risks?
While the AI might hallucinate based on that proprietary input, it could subtly bias future outcomes for that user or even for others. But the most critical part is the terms of service.
The fine print.
The fine print that nobody reads. They often grant the provider these broad rights to retain that input data for future model training.
So the moment an employee hits enter.
The minute they hit enter, your company's sensitive data becomes, inextricably embedded in the weights and parameters of a public model.
That's not a breach, that's forfeiture.
It is an immediate and permanent forfeiture of confidentiality. It's gone.
That distinction static storage versus probabilistic opaque processing is genuinely terrifying. So if that's the fundamental difference, let's categorize the operational threat. The sources break this down into 3 distinct threat vectors.
They do. And the first one is the most common one. Consumer-grade Gen AI platforms.
This is the everyday stuff.
This is the everyday threat. We're talking about the vast majority of employees. They're using the free tiers or their personal accounts on public platforms like ChatGPT, Claude, those little summarization tools.
Oh, they're just trying to be more efficient.
Of course. They're drafting a complex email about a confidential project. Or, and this is a scenario we see way too often, a developer pastes a tricky block of proprietary source code into the prompt window and just asks the AI to find a bug.
And the risk, like you said, is right there in the terms of service. But why doesn't just making employees sign an acknowledgement form work? Why does the breach happen instantly?
Because the model training mechanism is so powerful and immediate, if you're on a free tier, you are paying with your data. That's the transaction.
Right.
The provider isn't just holding your data in some secure folder. They're incorporating the semantic meaning and the context of your input into the model's vast knowledge base. Even if they promise to delete the input later, that knowledge it's already part of the model's fabric.
So it's irreversible.
It is instantaneous and irreversible. It violates contractual confidentiality agreements the second it happens. And it's the most prevalent vector because the tools are everywhere and the barrier to entry is zero.
Okay, that's vector one. But here's where it gets really technical and maybe even more interesting for our listeners. The threat of shadow models and local inference.
Correct.
This is where your highly skilled developers or your data scientists start actively bypassing cloud controls entirely.
That's it. When a good developer is blocked from accessing public APIs, they don't just stop working, they still have a job to do.
So what do?
They download open source models, things like Meta's Llama 3 or Mistral, and they run them locally, right on their workstations, using tools like Llama or LM Studio.
Now wait, running it locally?
Yeah.
That sounds safer, right? It's keeping the data off the public internet.
It sounds safer, but it creates these enormous hidden security gaps.
How so?
First, these models become these unmanaged silos of decision-making. They might get integrated into internal scripts or automated workflows, what the sources call shadow code.
Shadow code.
And this code is completely unvetted, it's unmonitored, and it could be introducing serious security flaws or bias into high-stakes corporate processes without anyone knowing.
Okay, that's one part.
The second part is that the tech staff running these models often spin up unauthorized cloud computing resources. We call this shadow cloud activity.
So they're just getting a server from Amazon on their personal credit card?
Pretty much. They'll provision a powerful GPU instance on AWS or Azure using a personal or maybe an unsecured departmental account just to run the model faster. And this shadow infrastructure, it frequently hosts unsecured training data sets, and critically, it often exposes hard-coded API keys.
And that's the real danger.
That's the catastrophic danger. Those keys can grant access not just to the model, but potentially to your entire corporate data lake. And your traditional perimeter security won't see any of this because it's happening inside a completely unmanaged cloud account.
So we have the general workforce leaking data to public models, and the tech staff building their own private, ungoverned AI infrastructure. But the third vector, this one feels like the most insidious. It's almost entirely invisible. Bring your own AI, or BYO AI.
This is the invisible bridge problem. It's so subtle. The employee isn't even going to a Gen AI website. They're just installing these small, seemingly harmless browser extensions.
Like what?
Think of a simple writing assistant, a grammar checker, a summarizer that promises to boost their efficiency by 20%. Seems great, right?
Wait a minute. So you're telling me an employee who installs a simple, non-malicious grammar checker is basically opening a back door for some third party to read their Salesforce data?
That is exactly what's happening.
That feels like a massive, invisible vulnerability. It bypasses everything we just talked about.
It does. To function, these extensions have to overlay their AI capabilities onto your corporate workflows. They require significant browser permissions, often read access to every single tab.
Every tab.
Every tab. That includes your sensitive enterprise web apps, Salesforce, Jira, your internal customer portals, your corporate HR system. So by installing that one little extension, the employee effectively grants an unknown, unvetted third-party AI data collector the ability to read all the confidential data flowing through that browser session.
It's just a constant data stream leaving the company.
A silent, persistent data stream.
Okay.
And it's invisible to the firewall because it's all authenticated and running inside the browser's own context. It's a huge blind spot.
Okay, now that we know what shadow AI looks like, let's try to quantify this problem, because the numbers here, they really provide the urgency, don't they?
They really do.
Our sources, they're providing metrics from early 2025, and they confirm this widespread, frankly, explosive loss of control. Let's start with raw traffic, because that shows the velocity of adoption.
And the velocity is just unprecedented. Web traffic globally to the major Gen AI sites surged from 7 billion visits in February 2024 to over 10.53 billion visits by January 2025.
That's an incredible jump in less than a year.
It's a massive accelerating shift in behavior. And here's the critical point for you if you're a security architect. 80% of that adoption is happening via standard web browsers.
So if you aren't controlling the web gateway,
You are losing 80% of the battle right there.
that explosive growth obviously means people are using them. But how much sensitive data is actually flowing out? What's the data leakage reality here?
The leakage is systemic. It's not an isolated problem. Research shows that 57% of employees admit to inputting sensitive data.
Over half.
Over half.
Yeah.
And not just generic questions. We're talking proprietary information into these shadow tools.
Can you measure that?
We can. To give that a number, security vendors logged over 313,000 separate paste attempts into Gen AI interfaces in a single typical month.
So 313,000.
In 1 month. Just let that number sink in for a second. That's an organization just hemorrhaging data continuously and often without even realizing it. And this behavior, it correlates directly with a doubling of overall data loss prevention, or DLP, incidents related to AI in early 2025.
So there's clear evidence of systemic leakage, which leads to the big question. What is the tangible bottom line cost of inaction? Does this actually lead to measurable financial damage that warrants this level of investment?
Oh, absolutely. It's quantifiable and it is severe. The sources show that organizations with documented high levels of shadow AI usage incur breach costs that are, on average, $670,000 higher than their counterparts with strict governance.
$670,000 higher.
Higher. And that money is spent cleaning up the damage, dealing with the intellectual property losses, and increasingly battling regulatory fines or lawsuits because some unvetted shadow AI model was used for a high-stakes decision.
Like in hiring or something.
Exactly. Potentially violating specific anti-bias laws. And the projections, they're even starker. Shadow and unauthorized AI use is projected to drive more than 40% of all AI-related data breaches by the year 2027.
40%.
So if you don't address this now, you are building a massive exposure for your organization's very near future.
That context is it's vital. And it brings us to the human element. We can't just treat employees like they're malicious actors.
No, you can't.
We have to understand the behavioral economics, the productivity imperative that is driving them to take these risks. They are making a rational calculation, right? Even if it's based on flawed security premises.
They absolutely are. The driving force isn't malice. It's a high demand for cognitive assistance. When your IT or security procurement process takes weeks or months to approve a tool, employees see that friction as an obstacle to their performance.
They've got deadlines?
They have deadlines, they have KPIs, and AI helps them meet them faster. The technology is simply outpacing the bureaucracy.
Which leads directly to this speed versus bureaucracy trade-off.
Precisely. Employees explicitly cite the desire to work at AI speed and the lack of readily available official corporate-approved tools as the primary drivers.
It's a simple calculation for them.
It is. If corporate vetting takes 2 months to approve a secure tool, but your peer, or maybe your competitor, can use the free version today to generate code or summarize a 50-page document instantly, well, the employee facing that deadline will choose speed. Every single time. The incentive structure is just broken.
And the barrier to entry is zero, which creates this zero-cost illusion.
This is such a critical factor in why discovery is so hard. The freemium model that all the major AI providers use has eliminated the traditional financial tripwire.
What do you mean by tripwire?
Well, traditional enterprise software required a purchase order, right? A budget code, a manager's sign-off. All of these were financial transactions that would trigger an alert somewhere in the IT department.
Well, with AI.
With these AI tools, you can access them instantly with just a personal email and at no cost. There's no financial alert that rings in the IT department. It completely bypasses all the traditional purchasing and discovery mechanisms.
And finally, there's the professional pressure, the social pressure, what our sources call competence signaling. This feels like the psychological driver that overrides caution.
It's a massive invisible pressure. In today's competitive labor market, proficiency with AI is quickly becoming a requirement, not a bonus.
It's table stakes now.
It really is. We know 97% of office workers believe AI boosts their productivity. Some report saving up to 6 hours a week. Now imagine you're on a marketing team and you see your peer generating 3 campaigns a week using a shadow tool.
You feel like you're falling behind.
Exactly. The fear of being seen as slow, inefficient, or technologically outdated becomes this massive professional risk that just overrides the security risk. To that individual employee, falling behind their peers is a greater threat to their career than violating a security policy they might not even fully understand.
So you have to address that fundamental conflict.
You have to. And it has to be addressed through culture, not just through technology.
Okay, so that's the problem.
Yeah.
It's huge, it's complex. Let's pivot to the solution.
Before any organization can deploy technical solutions, before you block a single domain or deploy a CASB, you have to establish a strong juridical and ethical framework.
The governance foundation.
Exactly. Without this governance foundation, any technical block is just going to seem arbitrary, which only encourages people to find ways around it. Governance provides the mandate for all the controls we're about to discuss.
So where do you start?
You start by aligning with global frameworks. You can't just write an ad hoc internal policy on the back of an envelope anymore. It won't cut it. Your governance has to map directly to established international standards, like the NIST AI Risk Management Framework and ISO/IEC 42001. That's what makes it defensible.
Let's focus on the NIST AI RMF, because for U.S.-based organizations and anyone dealing internationally, it really is becoming the gold standard for proving due diligence. How does that help manage the chaos of shadow AI?
The NIST framework is brilliant because it's a consensus-driven four-step checklist. It helps you structure your entire strategic response. It moves you from a state of panic to a process.
What are the 4 steps?
The first is govern. This is the bedrock. You have to formally establish the organizational structure. That means drafting robust, acceptable use policies, creating a cross-functional AI ethics council, and formally defining your organization's risk appetite for Gen AI.
So, getting everyone on the same page.
Top-down clarity on what data can and absolutely cannot touch a public model. Then second is MA.
Map the risk.
This is where you contextualize the risk. It involves automated discovery through logs and CASB, which we'll cover in a bit. It means running internal employee surveys to understand what shadow tools are actually being used. And crucially, it means accurately classifying your data so you know what's most exposed. PII, PHI, source code, IP.
Okay, govern. Map. What's third?
Third is measure. You have to quantify the actual impact. This means assessing the frequency of your DLP incidents that are driven by AI, but it also means measuring things like model drift or inaccuracies that come from relying on these unvetted shadow tools.
So you're linking security risk to business risk.
Directly. You demonstrate why compliance actually matters to the bottom line. And finally, the fourth step is manage.
The action plan.
This is where you prioritize and you treat the risks. You deploy the blocking technologies. You implement mandatory human-in-the-loop verification processes. And critically, you provision those sanctioned, secure alternatives we talked about.
And you mentioned ISO/IEC 42001. How does that standard fit in, especially with third-party risk?
ISO 42001 is critical because it forces you to extend your existing third-party risk management, your TPRM program, to specifically include AI vendors.
Because the LLM providers are third-party vendors.
Exactly. The rise of shadow AI means your employees are bypassing procurement and effectively establishing relationships with these high-risk third-party vendors without any oversight.
So what is the standard mandate?
It mandates that you rigorously vet the data retention, training, and security policies of any tool your employees want to use. This creates a formal check phase. If a vendor can't demonstrate compliance, specifically zero data retention and strict encryption, then that tool cannot be allowed.
So it slows down the adoption of the unsafe tool.
Automatically. Most public models just fail this vetting process.
Okay, so once that strategic framework is set using NIST and ISO, the organization needs the actual tactical document, the acceptable use policy, AUP. And our sources are clear, your generic computer usage policy just won't work here.
It completely fails. It doesn't capture the semantic and probabilistic nuances of Gen AI. The AUP has to be granular and extremely clear.
So let's talk about the critical clauses, what has to be in it.
It starts with the most basic yet most violated rule, data classification and restriction.
Be explicit.
Extremely explicit. The AUP must prohibit the input of data that's classified as confidential, secret, PII, or PHI. Think about this quarter's unaudited financial forecasts or internal customer support tickets.
Things you would never email outside the company.
Exactly. Employees need to know instantly which documents are safe to summarize and which ones are a fireable offense to paste into a public model.
What's next?
Next is the mandatory output verification, or human-in-the-loop, HITL, requirement. The risk of hallucination isn't just operational, It's a legal liability.
So you can't just trust the output.
You can't. The policy must mandate that employees verify any AI-generated code, content, or citations against trusted internal sources before they use or deploy it. This is key because it shifts the legal and operational accountability for accuracy and security flaws, like a hallucinated piece of code that introduces a bug back onto the human user.
That's a vital legal safeguard.
It is. And then you need to be specific about the risk areas, addressing regulations directly.
The high-stakes decisions.
That's right. The policy has to strictly forbid the use of shadow AI for things like automated processing of job applications, firing recommendations, or lending approvals, unless there's a formally audited and approved internal process.
Why is that so important?
It's mandatory to comply with specific bias regulations, like the New York City AI bias law, which requires assessment of tools used in employment decisions. Letting a shadow model make these decisions risks serious legal exposure and discrimination claims.
And finally, to make sure it's all taken seriously, the policy needs teeth.
Sanctions and enforcement have to be clearly articulated. The policy has to detail the disciplinary consequences up to and including termination for bypassing security controls or exposing sensitive data. This sends a crucial signal that AI security is a board-level priority. It provides the deterrence you need to counteract that productivity pressure we talked about.
All right, so governance establishes the rules.
Yeah.
But rules are useless if you can't see who's breaking them. The next technical step is not blocking, it's discovery.
You cannot secure what you cannot see. It's
Yeah.
that simple.
And we established most organizations are dramatically underestimating their shadow AI footprint.
Dramatically. And the starting point for discovery should always be leveraging the infrastructure you already have. That begins with enhancing your network visibility.
The most immediate low-hanging fruit here has to be DNS analysis.
Absolutely. DNS is essentially the phone book of the internet. IT teams can simply analyze their DNS resolution logs and identify queries going to domains associated with GenAI. You know, star.openai.com, star.anthropic.com.
And what does the data show?
The data is a massive wake-up call. DNS queries to these GenAI domains saw a 279% increase year over year. That is a huge, quantifiable signal of adoption across your enterprise. It often reveals departments you never suspected, like HR or legal, are heavy users.
Okay, beyond DNS, firewall inspection also has a role to play, moving beyond just domain names to look for traffic anomalies.
Yes. Your next-generation firewalls, your NGFWs, they can detect the high-volume HTTPS sessions that are characteristic of extensive AI interaction. But more sophisticated analysis looks for anomalies, like a sudden spike in upload traffic from a workstation that usually only downloads.
So a big outbound data transfer.
Right. A large, unexpected upload often indicates a big file or a chunk of source code is being moved to an LLM, and that should trigger an immediate security alert.
But firewalls and DNS, they're often focused on the port and the IP. They're perimeter tools.
They are.
We need tools that can inspect the content and the context of the traffic itself. And that's where CASB discovery methodologies, cloud access security brokers become indispensable.
CASB is essential here because it's designed to move beyond that binary perimeter. It inspects the application layer, layer 7, where the actual interaction is happening. They are the core of sophisticated cloud activity detection.
How do they work?
A CASB performs automated app discovery. They use these vast, continually updated databases to instantly categorize the traffic they see. They assign a quantitative risk score, often called a CCI, a cloud confidence index, based on the vendor's documented security posture.
So they're checking things like their data retention policy.
Exactly. Does the LM vendor claim ownership of your data? Are they SOC2 compliant? Do they encrypt data at rest? This process generates an instant, quantified shadow AI inventory. It lets the CIO prioritize which tools to block based on real, assessed risk, not just rumor.
And CADs are also key to catching that dangerous developer threat, the shadow cloud, which traditional cloud monitoring often misses.
Precisely. Shadow cloud detection is critical for controlling that infrastructure risk. A CASB can identify developers who are bypassing your standard enterprise cloud controls. It can detect them spinning up unauthorized compute instances on their personal AWS or Azure accounts specifically to host a private model.
And that's where the API keys are exposed.
That shadow infrastructure is a prime source of major leaks, like exposed API keys. By detecting the unauthorized resource, the CASB gives you visibility into the environment where these shadow models live.
Okay, for a complete discovery picture, we have to look beyond the network and cloud and get onto the devices and into the code itself.
That brings us to endpoint and code scanning. The first part covers that really subtle BYO AI vector.
The browser extension.
The browser extensions. Endpoint agents are lightweight software you install on corporate devices. They're designed to detect the installation of unauthorized local AI tools like Llama or, crucially, these problematic browser extensions. If an employee installs a summarizer, the agent flags it based on its permission profile. If it's asking for read access to too many sensitive corporate domains, it's instantly flagged as a high-risk BYO AI tool.
And for the developers, we need to scan the code repositories, which are often treated as this trusted internal environment.
Code repository scanning is vital for preventing what we call the shadow supply chain risk. Organizations have to scan their internal repos, GitHub, GitLab, what have you, for hard-coded API keys that point to external public AI services.
Because if a developer integrates an OpenAI key directly into the production stack,
then that model now has a permanent, unmonitored connection to external services. This is not a one-off paste. It's a persistent vulnerability built right into your application itself. Scanning catches these integrations before they lead to a catastrophic, persistent data exposure.
okay, we found the shadow, we know who's using what and where. Now we have to actually stop the data flow. The strategy has to shift from just simple, blunt blocks to more granular, context-aware enforcement.
Right, let's start with the basics. Network blocking. It's the necessary first line of defense against the known high-risk vectors.
Like DNS filtering.
DNS filtering is fast and effective. You categorize and block traffic to non-compliant GenAI domains. You essentially black hole the connection before it even resolves. It's an immediate stabilization measure for the most egregious sites.
And firewall rules.
Similarly, firewall rules can block specific IP ranges. But the sources note a huge challenge here. The proliferation of new AI domains is so fast that static block lists are just insufficient. You have to rely on dynamic threat intelligence lists from major security vendors to keep up.
But the real sophistication comes when we move to the Security Service Edge, or SSE, and CASB enforcement. This is where we get past that binary allow block to that critical philosophy of allow but verify.
The ability to control specific activities is the game changer here. With a CASB's activity control, you can set a policy to allow view access to a GenAI site. Maybe an employee needs to read a response, but simultaneously block the specific activity's post, upload, or paste.
So you let them research, but you don't let them exfiltrate data.
It's surgical security. You apply it to the specific high-risk actions.
What else can advanced CASBs do?
They offer instance awareness. This is really powerful. They can distinguish whether a user is logging into a public service, say google.com, with their corporate Google Workspace identity versus their personal Gmail identity.
So you can enforce tenant restrictions.
Exactly. You ensure sensitive data only flows to the sanctioned, legally protected enterprise tenant and not to a user's personal account, even if they're on the same corporate network.
And if an employee does try to access a blocked tool, the CASB can coach them in real time. That addresses the behavioral side of things.
This is the key to driving culture change. Instead of a frustrating, hard error message, the CASB redirects them to a real-time coaching page. This page explains why the tool is blocked, warning, this tool does not guarantee zero data retention, and provides a one-click link to the approved corporate alternative, like Copilot.
So you guide them to the safe option.
You reinforce the AUP in the moment of need and reduce the frustration and the incentive for evasion.
Okay, moving on to data inspection, we need to talk about advanced DLP for LLMs. You mentioned traditional data loss prevention fails here. Why?
Traditional DLP was built on simple pattern matching. It looked for predictable sequences, a 16-digit credit card number, a 9-digit social security number. That approach is completely inadequate for unstructured proprietary data like internal memos or source code, which don't have those standard PII markers.
So we need NLP-based DLP.
Absolutely. Modern DLP tools, integrated into the SSE stack, use natural language processing to understand the semantic meaning of the data. They can tell that a user is pasting a block of proprietary Python code or a confidential memo about a merger into a chat interface, even without exact pattern matching. That deep context awareness is mandatory.
And the most sophisticated measure discussed in the sources is using middleware for redaction pseudonymization. This sounds complex.
It's truly advanced defense, but it lets employees use powerful external models without exposing the core data. These technologies act as a security layer or middleware sitting in the middle of the communication stream.
How does it work in practice?
An employee enters a prompt like, analyze the PII of Jane Doe in the Q4 report. The middleware intercepts that prompt. It identifies the sensitive entities, Jane Doe Q4 report, replaces them with generic tokens like entity alpha, project beta, and sends the sanitized prompt to the external AI.
So the AI never sees the real data.
Never. It gets the generalized response back, and then the middleware rehydrates it, replacing the tokens with the original sensitive data before delivering it to the employee. You get the power of the external model without the data exposure.
Finally, we need to look at the new layer of security tools designed specifically for the AI stack, the emerging control plane.
It's a whole new world. First, you have AI Security Posture Management, AISPM. This is like the Cloud Security Posture Management, or CSPM tools you already know, but it focuses entirely on the AI stack itself.
So what does it look for?
It connects to your cloud environments to detect unauthorized model deployments, like a developer spinning up a rogue Llama 2 instance on a public server. It finds misconfigurations like publicly exposed API keys or over-permissioned access to training data. It ensures the infrastructure is compliant.
And for internal applications, the AI firewall becomes mandatory.
Yes. An AI firewall sits at the application layer and inspects the prompts and completions in real time. It's essential for defending against attacks that target LLMs directly.
Like prompt injection.
Exactly. It defends against attempts to jailbreak the model to bypass safety filters, and it ensures the output isn't toxic, biased, or inadvertently leaking PII back to the user. It's a critical runtime shield for any internal AI application.
Okay, so we've covered policy, discovery, and enforcement, but that feels very negative. It's the Department of No.
And we come back to the core lesson of security history. Blocking technology without providing a viable, superior alternative is guaranteed to fail.
Employees will find a way.
They always find a way. The strategic shift here has to be from the Department of No to the Department of Secure Enablement. We must offer what the sources call Sunlight AI sanctioned alternatives that are so good, they naturally kill the incentive to use the shadow tools.
Let's look at the best architectural pattern for this, the Enterprise GenAI Gateway.
This is the single most effective way to centralize control. The gateway is an API management layer, a middleman, that acts as the only sanctioned entry point for all internal AI traffic. Users have to authenticate via corporate SSO against the gateway first.
So every interaction is tied to a corporate identity.
And the gateway becomes your security engine. It routes the user's request to the right backend Model GPT-4, Claude, and internal Llama instance, but only after passing the request through your critical security filters. PII redaction, prompt injection defense, comprehensive logging, rate limiting.
The huge benefit isn't just security, it's agility.
Exactly. You gain centralized auditability for compliance, and your developers get the seamless single API access they crave. And you can swap out the backend LLM provider without ever disrupting the front-end applications your employees use. It solves the speed versus bureaucracy trade-off.
Okay, moving to the actual tools, organizations need to provision commercial enterprise tools with clear, zero data retention contracts. What are the leading options?
For organizations deep in the Microsoft ecosystem, Microsoft Copilot for M365 is the ideal default solution. It's a massive reduction in shadow risk.
Why is it so effective?
Because Copilot operates entirely within your organization's existing M365 tenant boundary. It inherits all your existing Microsoft Purview security and compliance policies. The key feature is that data does not leave the tenant boundary to train public open AI models.
So it's safe for summarizing internal documents.
It's the safest default for document summarization, email drafting, internal data analysis. It just eliminates the need to paste sensitive documents into the public internet.
And for the power users who need access to the most advanced models but have to stay compliant.
For them, your data analysts, your specialized developers, ChatGPT Enterprise provides that necessary secure alternative. It offers SOC2 compliance, encrypted conversations, and administrative consoles for IT. Deploying this for the specialized teams, the ones most likely to build their own shadow models, removes their incentive to use personal accounts.
Finally, we address the most sensitive data, M&A strategies, proprietary source code. Even enterprise public APIs might be too risky. So we move to the AI playground and private hosting.
This is the ultimate control solution. For data that absolutely cannot leave your premises, you have to use open source models like Llama 3 or Mistral, hosted on air-gapped or VPC deployments.
So you're running it on your own cloud infrastructure.
Entirely on your private cloud or on dedicated internal GPU clusters. This ensures total data control. The data never leaves your defined security boundary.
But is that fast enough? Is it cost effective?
To make it practical, you use efficient inference engines like VLLM to serve these models cost effectively. The end result is what the sources call a walled garden or an AI playground. And employees prefer this internal tool
Why?
because it's free to them, it's integrated seamlessly with internal data, it's often faster because of proximity, and they know they won't get reprimanded for using it. You make the safe option the superior option, and you choke off shadow AI organically.
We've covered policy and technology, but the source material is so clear that the lack of AI literacy is the core driver of risk. Employees just don't understand why pasting data is dangerous.
They see it as a calculator. They don't see their browser extension as a data siphon. You have to change the culture to view security as a collective responsibility.
And technology can handle the can, but culture handling the should.
Exactly. And top-down mandates rarely change ingrained behavior. You need advocates on the ground. That brings us to the AI Champion Program.
This program formally deputizes enthusiasts and technically proficient users across business units, HR, finance, engineering.
Their role is vital. They test the sanctioned corporate tools, they provide critical feedback to IT, they report the functional gaps that are driving shadow usage. They'll say, the corporate tool can't summarize PDFs over 100 pages, so we go to Claude.
They bridge the gap between IT policy and business reality.
And they mentor their peers, setting positive examples. Structurally, these champions should feed into a cross-functional AI council with security, legal, and product teams. This council guides strategy, and critically, it democratizes the allow list process, making it faster and less bureaucratic.
Speed in governance is the only way to fight the speed of shadow adoption.
We've got it.
Next, we address training. Passive annual compliance training is useless here. Training has to be gamified and role-specific.
Absolutely. It has to be continuous, interactive, and relevant. A key method is simulation, running shadow AI phishing campaigns.
What does that look like?
You present employees with a tempting, unverified AI tool in a simulated scenario. An ad pops up saying, generate your Q4 report summary instantly. If they click or try to input sensitive data, it triggers an immediate role-specific teachable moment about the policy violation and the risk. It's so much more effective than a slide deck.
And the curriculum itself needs to go beyond standard security awareness.
It has to cover AI-specific risks, the reality of hallucinations, why you can't blindly trust the output, data poisoning, deepfake awareness, and the training has to be tailored. What an engineer needs to know about source code leakage is totally different from what an HR manager needs to know about PII exposure.
And finally, how do we measure success? It can't just be a completion rate.
No, you measure it with behavioral metrics. The goal is to track the reporting rate, how often are employees proactively reporting a new unverified tool, and the dwell time, how long is a shadow tool acting on the network before it's detected and shut down. That's how you know if your employees are becoming proactive security sensors instead of reactive risks.
This has been a massive deep dive into a crisis that is fundamentally redefining enterprise security. We've established that the required shift isn't panic, it's strategy, the hybrid governance model.
A model that relies on 4 interlocking pillars. First, ruthless visibility through tools like CASB and AI SPM. Second, strict interdiction via DNS and secure web gateways. Third, aggressive enablement by rapidly provisioning safe, superior alternatives like gateways and Copilot.
And
finally, continuous culture building through AI champions and that gamified role-specific training.
By implementing this strategy, organizations are moving the IT function from a place of restriction to a place of innovation, using control to accelerate the speed of the business.
Precisely. By moving the IT organization from a department of no to a department of secure enablement, organizations turn this chaotic, uncontrolled risk shadow AI into a governed strategic asset. An asset that not only protects their IP, but actually drives their competitive advantage in this new AI-driven economy.
We've established that the speed of AI adoption is absolutely outpacing organizational policy, driving huge risks to IP. For you, the listener, the next challenge isn't just knowing what your company allows, but truly understanding the specific data retention and model training policies of every single large language model you interact with on a personal level.
Whether you use it for a hobby or just a quick query.
Because today's shadow input made during your lunch break on a public tool could easily become tomorrow's permanent public model weight, defining its output and exposing data you never intended to share. That's something to think about.